Well, let's continue talking about the advanced options available in this section. The credit specification option only applies to certain instances. Let's see more details about this. The credit specification option applies to Amazon EC2 variable or scalable performance instances, also known as T instances. These include the T2, T3, T3 and 4 Gramps instance families. Therefore, if you attempt to launch any other instance type, the credit specification option will not be available. These instances belong to the general-purpose instance family and are designed for workloads that do not constantly need high CPU performance. Examples are web servers and small databases that have fairly average utilization and do not need constantly high CPU performance. Now, they are called variable or scalable performance instances because they provide a baseline level of CPU performance with the ability to scale up or burst above the baseline level if needed. The AWS documentation describes the basic performance of variable performance instances. Here we have the different types of instances and their base utilization per vCPU. For example, for a T2 micro instance, the base performance is 10% per vCPU. Then, when the instance utilization stays below the baseline, it earns CPU credits per hour. These credits can be used to exceed the baseline if necessary, such as when the server experiences high utilization. So it is the CPU credits that determine whether these instances are allowed to exceed the baseline CPU level. Now, these instances can be configured in one of two modes, standard and unlimited. When set to standard mode, if the instance exceeds the base CPU level, it first uses the accumulated credits. When it runs out of accumulated credits, it gradually drops down to the base CPU level and cannot burst or increase above the base level until it accumulates more credits. As you can imagine, there may be situations where this is not ideal. The instance may need more CPU power, but being in standard mode, it cannot go above the baseline, and for such use cases, you can use unlimited mode. Therefore, when configured in unlimited mode, if the instance exceeds the CPU baseline, it first uses the accumulated credits. When it runs out of accumulated credits, it uses the leftover credits to burst or increase. In other words, it borrows credits. When its performance falls below the baseline, it uses the credits it earns to pay back the surplus it borrowed. This mechanism allows the EC2 service to average CPU utilization over a 24-hour period. If the 24-hour average is above the baseline, additional charges apply. By using the unlimited mode, you have the assurance that your EC2 instance will be able to burst or increase above the baseline even if you run out of CPU credits. If your application constantly requires high CPU, it is recommended to use fixed performance instances rather than variable or scalable performance instances. The next option is called Placement Group. This setting allows you to influence the placement of instances on the underlying hardware. Normally, when you launch multiple EC2 instances, you don't tell AWS how these instances should be placed on the underlying hardware. But with placement groups, you can tell AWS to place your instances close to each other in a single availability zone for low latency, or to spread your instances across the underlying hardware to reduce correlated failures. We'll talk more about this in an upcoming class. The next option is EBS Optimized Instance. Certain instance types offer dedicated capacity for EBS ingress and egress, which optimizes EBS performance. It is crucial to remember that EC2 instances and EBS volumes are hosted on different underlying hardware. This implies that they do not share hardware, and that there is a specific connection between EC2 instances and EBS volumes. In some cases, this connection can become a performance constraint. However, by using an EBS-optimized instance, you can guarantee dedicated performance for your application. But note that this option is only supported for certain instance types. Then there are the purchase options. For example, capacity blocks allows you to launch instances for your active capacity blocks, that is, reserves of computing capacity that you have acquired. And spot instances are instances that you can request at a variable price, known as spot price, which will never exceed the on-demand price. We talked about this in a past class. Each option has its own advantages and can be useful depending on your specific computing needs and budget. The next option is capacity reservation. Capacity reservation, as it sounds, allows you to reserve EC2 capacity. Sometimes AWS may not be able to launch your EC2 instance because there is no available capacity. Normally, you won't see this behavior when you launch a few instances, but if you launch enough instances, AWS may not be able to fulfill your request. Using the capacity reservation will guarantee you access to EC2 capacity. We will talk more about this later as well. The next option is the tenancy. This option will determine whether your instance will be launched on shared or dedicated hardware. There are two options available for dedicated tenancy: dedicated instances and dedicated hosts. We will explore the details and differences in an upcoming video, as this is a topic where you need to pay close attention. The next option is RAM disk ID. A RAM disk is a virtual disk created in the memory or RAM of an EC2 instance. Its main advantage is that it offers much faster data access than traditional hard disks, which can improve the performance of certain applications. However, it is important to note that the data on a RAM disk is volatile. That is, it is lost when the machine is shut down. Therefore, its use is recommended for temporary data or data that does not require persistence. The next option is the kernel ID. The kernel ID on an EC2 instance allows you to select a specific kernel for your operating system. The kernel is essentially the operating system kernel that manages access to the machine's hardware. Choosing an appropriate kernel can help you optimize the performance of your EC2 instance according to your needs. The next option is Nitro Enclave. This feature allows you to create isolated execution environments called enclaves. Because they are isolated, they can be used to handle sensitive data such as personally identifiable information, financial data, and intellectual property. This option is only supported for certain instance types. The next option is license configuration. AWS has a tool called License Manager that allows you to manage software licenses for products such as Microsoft and Oracle. Customers use it to track and monitor license usage. License Manager settings can be associated here to manage licenses for software running on your EC2 instance. The following options are related to EC2 metadata. EC2 metadata is data about your EC2 instance. It includes information such as the OMI ID, instance ID, host name, MAC address, IP address, security groups, and more. Essentially, it is data about your EC2 instance. For example, the accessible metadata option can be used to enable or disable access to metadata. Metadata is available in two versions, version 1 and version 2, and you can control the version from here. The next option is metadata response hop limit. The hop limit only applies if you use metadata version 2. Version 2 uses token-based authentication and uses session tokens that determine how long a session can last. When a session token is created, the hop limit, also known as TTO, or time to live, is set to 1 by default. Certain use cases may require a higher hop limit value and can be configured here. Don't worry if some of this doesn't make sense to you right now. We'll talk more about metadata later. The next option is to allow tags in the metadata. This option determines whether the tags of your EC2 instance will be available in the metadata. The last option is user data. It allows you to run custom scripts when an EC2 instance is launched. It can be used for reasons like installing software or starting a service when an instance is launched. For example, I can paste this script here, and what it will actually do is create and configure a web server on this instance. For now, I'll leave it blank like this since I won't be making use of it. So, as you can see, there are many options to configure your EC2 instance. All that would be left now is to launch my EC2 instance. But first, on the right side, as you can see, we have the summary of the configuration. If we want to launch more than one instance with this same configuration, I can indicate it here in this field. Here we see the only we chose, the instance type. A security group is going to be created, and we have the storage. Notice that with this configuration, we are inside the free tier, so AWS will charge absolutely nothing for it. Then I hit Launch Instance. And it's done. Here I get some recommended steps of what I might do after launching this instance. For now, I click on View Instance. And here we can see that the EC2 instance is in the process of being created. This usually takes about 4 to 5 minutes. Once this is done, you can see the configuration and you will be able to make use of it. So, this is how you launch an Amazon EC2 instance.